factor in the greatest common factor. We've done this in an earlier lesson, but we didn't really we weren't factoring out variables. We were just factoring out constant terms. So let's factor out a common factor here. Okay, so what's common in all three of these terms? 3. So I can pull out a 3. What do I have left? First term, just left with an x squared. Minus 3 goes into 12 4 times, so I've got 4x plus 2. Not a good looking plus, there we go. We can check these, right? So there's my answer. I can check this, I can distribute that 3 through. Let me rewrite this so I don't mess up my nice answer. I can multiply the 3, then to the negative 4, then to the 2. What do I get? 3x squared minus 12x plus 6, which is what I have up there. So I'm pretty confident I'm right. Okay, try these two. Pause the video, see if you can get these. All right, welcome back. So, what's common in these two? And when we say factor out a common factor, what we really mean here is the greatest common factor. It's sort of implied. I could factor out a 3 here. I could factor out a 1. We don't want to pull out the trivial one. So the biggest one I can pull out is a 15. And then what am I left with? Left with an x there, and then 15 times 1 is 15. So 1. And again, at the very least, mentally distribute that 15 on both terms, and you'll get my original expression. How about this next one? 6x squared plus 9x plus 3. What can I pull out? What's the largest term common in all three of these terms? Good, a 3. So 2x squared, what do I have left? Plus 3x plus 1. So you can do this one. Now here we have some variable terms we can actually pull out. So I start with my constant term. I can pull out a 5. And then what am I left with here? And in fact, let me leave myself room to pull out the variable term. I can pull out between the x squared and x cubed. What can I pull out? X squared. Good. Then what do I have left? Let's see. I've got a 2 left there. And I pulled out x squared, so I've got one more x left. Minus 1. And again, mentally go through. 5x squared times 2x is 10x cubed. 5x squared times negative 1 is 5x squared. What about part B? What can I pull out here? Let's see. 9 x y. That's all I can pull out, right? What do I have left in the first term? 2x squared minus, let's see, the 9's gone, x is gone, and one of the y's is gone. Just a y. Again, redistribute this through to check it. Oh, we got a lot of terms here. 4 terms. What's common? Let's start with the number. I can pull out a 4, right? Okay. I've got an x in all the terms, but I can't pull out any more than just a plain old x. I can't pull out any more than just a plain old y and a z. I could, but you end up with negative exponents. We don't want to do that. Keep a positive exponents. So what do I have left? First term, I got a 4 minus 2. Let's see, one of those x's is already gone, one of the y's is gone, and one of the z's is gone. So 2y z squared plus 6x, one of the y's is gone, and one of the z's is gone, plus 4 is gone. Let's see, x squared, and the y and the z are gone, so that's it. I'll leave it up to you to check that. Okay, factoring out a negative common factor. So often we want to pull out a negative factor. And we'll see that in subsequent lessons, why that's useful. So if I pull out a negative factor here, let's see, I can pull out a negative, what, 5x. What do I have left in this first term? Just an x. And then this is going to be a plus, right? Because I pulled out a negative from that. 2 negative, give me a positive, plus 2. Let's re-multiply. So that should be it. But if I multiply that back out, negative 5x times x is negative 5x squared. Negative 5x times 2 is a negative 10x. So I get what I started with. Okay, pause the video here, see what you can pull out of the part B. All right, welcome back. Okay, what can I pull out here? Just a negative 2. I can't pull out anything else. So what do I have left? X squared plus 2x minus 5. And I'll leave it up to you to redistribute that through. Okay, factoring by grouping. These can get a little tricky, so hang with me there. So factoring by grouping, what we do here is we group up. We put parentheses around the two of these terms. Notice when I put the parentheses around this one, that this here becomes a plus. Because notice if I redistribute that negative 1, what do I need to end up with? That needs to be a negative 12. So that changes the sign there. Now what do I do? Let's factor within each group. So within this first group, I'm going to pull out the x squared. Within this second group, I pull out what I can pull out, which is just a 2. Now what happens? Notice that this right here, x plus 6, x plus 6. If that doesn't work out, I cannot do factoring by grouping. This has to match exactly, x plus 6 and x plus 6. So I can pull out an x plus 6. And when I pull out the x plus 6 from this term, what am I left with? Just the x squared. I pull it out from this group. What am I left with? The minus 2. Because that's pulled out. It's sometimes hard to see a binomial factor getting pulled out. But it'd be exactly the same thing if I had this. What if I had x squared y minus 2y? How would I factor that? I pull out my common factor of y. And what do I have left? X squared minus 2. It's exactly the same thing, except instead of y, I've got an x plus 6. See what you can do on these. I've gone ahead and started you on them. Okay. Let's go ahead and factor out the common factor from both of these terms. So what's common in this first term and the second term? Hopefully it's just screaming at you, x minus 2. So I pull out x minus 2, and what do I have left? X squared plus 5, because those x minus 2's, I pulled it out. So x squared plus 5. And that's it. What about part B? Common is the 2x plus 7. What do I have left? X minus 3. How about this one? X cubed plus 2x squared plus 3x plus 6. Now we have to create the groups ourselves, like the very first example. So just put our parentheses around, and sometimes you've got to rearrange the terms to group them to where you can pull out what you need to pull out. So what can I pull out of this first group? Good, x squared, and what am I left with? X plus 2. Plus, I can pull out a 3 from the second group. I'm left with, well, isn't that nice? X plus 2. I can pull out the x plus 2. And I'm left with x squared plus 3. I can multiply that back out, and you should get what we started off with here. We'll just do a few more of these. Example 19. Okay, first grouping, second grouping. So what can I pull out of here? I can pull out a p, and I'm left with p plus 4. Plus, what's common in these two terms? Good, q. So I've got p plus 4. Well, isn't that nice? P plus 4, p plus 4. So pull out your p plus 4. And what are you left with? P plus q. And don't worry about that. Example 20. Try to do one of these on your own. Once you do a couple of these, they're not that bad. Okay, put my groupings around. And then what do I have? What can I pull out of this first group? A, and I'm left with A minus 2. Second group, pull up, and I'm left with A minus 2. Again, that's nice. I'm left with A minus 2 times A plus B. Now it's often asked, can I write it A plus B times A minus 2? Well, sure, these are equivalent, right? I mean, 5 times 3 is the same as 3 times 5. Multiplication is commutative. So yes, these are the same thing. Both of these are perfectly fine. Example 21. Try this one. Okay. Do my group. Except this time you got to be careful. When I put a parentheses here inside of a negative, that's going to change that sign. So I can pull out a 7z, and I'm going to be left with z plus 2, minus, pull out an a, and I'm left with z plus 2. Again, isn't that nice? If you ever end up with the signs a little bit, just the signs off, you may have forgotten to do that. So what can I pull out? Z plus 2, left with 7z minus a. Zero product principle. So we're going to be trying to solve for x, or for the variable, the unknown. So the steps are, you get 0 on one side of the equation, you factor, you set each factor to 0, and you solve each equation. Let's look at an example. So again, step 1, we're going to factor. Pull out your 6x, you get 6x times x minus 3 equals 0. Step 2, set each factor equal to 0. I have 6x equals 0, x minus 3 equals 0. Those are my two factors. And then solve for x. I get x equals 0, x equals 3. That's my answer. I can plug both of these in as a check in for x, and I should get a true statement. Okay, x squared minus 5x equals 0. Again, we did these earlier with the graphing calculator, but you need to be able to do these algebraically as well. So step 1, let's factor this guy. So pull out an x, you get x times x minus 5 equals 0, set each factor equal to 0, and solve for x. You get x equals 0 and x equals 5. Plug both of these back in, we should get a true statement. Do this one on your own. Trust me, once you do a couple of these aren't that hard. Okay. Pull out your common factor of 3x. You get 3x times x minus 2 equals 0. Set each factor equal to 0. Solve for x. You get x equals 0, x equals 2. This may be the last one. We have x plus 2 times x minus 2 equals 0. Let's solve for x. So set each factor equal to 0. Solve for x. X equals negative 2, x equals positive 2. Again, sometimes this is written as x equals plus or minus 2. I had one more. I should have those animate to come in, but that's okay. 2x minus 1 times x plus 4 equals 0. Set each factor equal to 0. Each factor equal to 0. And solve for x in the usual way. We get x equals 1/2 and x equals negative 4. Okay, a lot of examples.